I will be talking about the importance of the reaction between barium chloride and silver nitrates. This is my original reaction. And firstly, to tell you who discovered the reaction, it is unknown. And is the reaction reversible? It is irreversible. And what is the molar ratio of the reaction? The ratio is 1 to 2 to 1 to 2. So considering what mechanisms allow the reaction to take place, firstly, this reaction is a double replacement reaction, and it is a precipitation reaction which as a result acquires a precipitate at the end of the reaction. And the difference in the electronegativity in the reaction allows for the reaction to take place. So under what conditions does the reaction occur? As most of you know, the standard condition is the STP, which is when it's 0 degrees Celsius or 273 Kelvin, and when the pressure is 1 atm. So this reaction occurs in STP, standard condition, and in water because it's aqueous reactions, and the silver chloride precipitates with low solubility in water. So to tell you the most important thing, the industrial applications of the reaction. Firstly, BaNO3 which is the product of the reaction, is an oxidizing and reducing agent, and it is also propellants and blowing agents as well, which are really important in laboratory settings. And for the another product, which is AgCl2, the silver compound has many antimicrobial uses, from stained glass to the creation of photochromatic lenses. And mostly this is used in creating bandages or wound healing products. And as I stated before, it is used to create yellow, amber, and brown shades in stained glass manufacture. So how efficient is the reaction? This reaction could be said that it is quite efficient because when considering the efficiency of the reaction, we have to consider whether how much of the products or if the reactant is completely used to produce the product, and how much product is produced per reactant. If we consider this, we say that this reaction is not completely efficient but quite efficient. And to tell you the entropy, enthalpy, and Gibbs free energy in the environment the reaction occurs, firstly, the entropy change is 57.10 joule per Kelvin, which means that the entropy has increased, and the enthalpy is negative 105.64 kilojoule, which shows that the reaction is exothermic, and the Gibbs free energy at 298.15 Kelvin is negative 122.66 kilojoule, which means that the reaction is spontaneous. And the properties of the chemical reaction before the reaction, which are the reactants, are BaCl2 has a molar mass of 208.23 gram per mole, and it is a white solid and has a density of 3.857 gram per centimeter 3, and the boiling point is 1560 degrees Celsius, while the melting point is 962 degrees Celsius. And BaCl2 is soluble in methanol and insoluble in ethanol or ethyl acetate. AgNO3 has a molar mass of 169.872 gram per mole, and it is solid in room temperature, and it has a density of 4.35 gram per centimeter to the 3, and has a boiling point at 440 degrees Celsius, and it decomposes at this boiling point and has a melting point at 209.7 degrees Celsius. This reactant is soluble in water, acetone, ammonia, and it is odorless. To tell you the properties of the reaction after the reaction, which is the properties of the products, BaNO3 and AgCl. AgCl has a molar mass of 143.32 gram per mole, and it is a white solid and has a density of 5.56 gram per centimeter to the 3. has a boiling point at 1547 degrees Celsius and also a melting point at 455 degrees Celsius. This AgCl is soluble in water and insoluble in dilute acids and alcohol. BaNO3 has a molar mass of 261.337 gram per mole. It has a shape of white lustrous crystal when in room temperature and has a density of 3.24 gram per centimeter to the 3. Also has a boiling point. It decomposes and has a melting point at 592 degrees Celsius and is soluble in water, insoluble in alcohol, and is odorless compound. So I'll tell you about the bonds of the reactant and products. And the bonds, AgCl2 is ionic, BaCl2 is also ionic, AgNO3 is ionic, and PaNO3 is combined with an ionic bond. And this is the reference that I have used in gathering my information. And the reason why this reaction should be conducted in many aspects is because, as I stated before, AgCl2 and BaNO3, which are the products in the reaction, are really important in laboratory settings as well as in industrial settings. I want to emphasize again, AgCl is used in wound healing products and bandages, and in everyday life we always use bandages when we get hurt. So AgCl is really important in forming these bandages. And it also creates yellow shades in stained glass, where stained glass is used in decorating churches or other important architecture. So this is the importance of AgCl2. And for BaNO3, as I stated before, it is really essential for laboratory settings because they are used to oxidize or reduce other chemicals or substances. So they are oxidizing and reducing agents, so they are really important. So these are the reasons why the reaction between BaCl2 and AgNO3 must be conducted.